Clothes that put themselves on? Sounds a bit out there. But for elderly or people suffering from mobility issues, this wearable exoskeleton that attaches to clothes and helps you put them on solves a life challenge. Called the WION robot, this is an inflatable device that gently puts clothing over the body without complicated motors or rigid mechanical arms.
Getting dressed is something most people do without a second thought. But for people with limited mobility or workers who need to put on protective clothing quickly, it can be a challenge. Researchers from the Korea Advanced Institute of Science and Technology, in collaboration with Stanford University, have developed a soft robotic dressing system designed to automatically help a person put on clothing. The system uses a special type of soft robot known as a WION robot, which is integrated directly into the garment.
The principle is that, as the soft-growing WION robot extends, it pushes the end of the clothing, pressing the clothing toward the person and helping them put it on. So, the WION robot stays close to the person and dresses them by turning the garment inside out as it moves, allowing it to climb stably along the shape of the body. Also, while the speed varies depending on the air pressure, using the WION robot to dress someone can generally put the clothing on in around 10 seconds.
Unlike conventional robots that move their entire body, the WION robot advances by growing only at its tip. When air is pumped into the robot, folded tube-like sections inside the clothing inflate and unfurl. As the robot extends, it gently pulls the fabric over the wearer's body by turning the garment inside out. Because the robot remains close to the body while moving, it reduces friction and eliminates the need for complex motion control systems or precise body positions. The entire process of putting on a full suit takes around 10 seconds. The design was inspired by the way climbing ivy grows along surfaces.
A WION robot has inherent compliance. It has the advantage of being able to grow while naturally conforming to a person, much like ivy climbing a wall.
Rather than pushing its entire structure forward, the robot continuously extends from its leading edge. This allows it to follow the natural shape of the human body while remaining stable during movement. The robot can also move through narrow gaps and adapt to different surface conditions, including smooth, rough, sloped, or sticky surfaces.
Rather than the robot's entire body moving, it moves as its tip grows forward, and this brings many advantages. In particular, it can pass through narrow gaps, grow while adapting to the shape of its surrounding environment, and move regardless of whether the surface is slippery, sticky, or sloped.
The flexible design makes it suitable for a wide range of body shapes without requiring individual calibration. The idea for the project came from a simple everyday situation. The lead researcher imagined a cyclist caught in the rain while carrying a backpack with both hands occupied. That led to the concept of clothing that could be worn automatically without manual assistance. Beyond everyday use, the team believes the technology could help elderly people, individuals with disabilities, and patients with limited mobility who may struggle to raise their arms or put on clothing without assistance.
I believe this robot could help elderly people or people with disabilities get dressed more comfortably by assisting them with putting on clothes. In the future, it could also be used in workplaces where people need to put on and take off special clothing quickly, such as clean room suits, protective suits in medical facilities, or uniforms used on semiconductor production lines.
The researchers also see industrial applications in environments such as semiconductor fabrication facilities, pharmaceutical plants, and hospitals. Workers often need to put on specialized protective clothing quickly and correctly. An automated dressing system could reduce preparation time while improving consistency. While much of today's attention is focused on artificial intelligence software, this system shows how innovative mechanical design can solve complex problems without relying on sophisticated control algorithms.